Hello, everyone. Welcome to today's webinar, AI-Driven Decision-Making, How Artificial Intelligence is Reshaping Asset Management. We are excited to have you. Today, we'll be speaking with experts from Copperleaf and Vale to learn how AI capabilities can be a lifeline solution for utilities. Now, today's utilities teams are tasked with facing a number of unprecedented challenges, from climate change and aging infrastructure to pandemic recovery. Many are being pushed to the breaking point as they try to adapt to meet these significant hurdles while continuing to deliver service reliably and safely to their customers. Optimizing the performance of assets across utilities' entire life cycle and making the right investment decisions is more critical than ever before. So in this presentation, we'll explore how the world's leading organizations are leveraging AI to maximize asset value, predict future needs, and optimize their decision-making in alignment with their strategic goals. Now, before we get started, just a few housekeeping items. Please note the slides will advance automatically throughout the presentation. To enlarge the slides, click the Enlarge Slides button in the top right-hand corner of your presentation window. If you need technical assistance, click the Help widget on the bottom left corner. Now, we do encourage you to submit questions at any time throughout the presentation using the Q&A widget at the bottom. Now, we'll answer as many questions as we can at the end, and if we aren't able to address them during the presentation, we will follow up via email. So please, just to let you know, we do capture all of your questions. And after the presentation, you will also be able to access the on-demand recording of the webinar using the same link from today's live event. Now for some introductions. I'm Laura Beth, and I will be your moderator for today's program. Now I'd like to introduce today's speaker panel. We are excited to be joined by Malcolm McRae, Head of AI and Advanced Analytics at Vale, one of the world's largest mining companies. Malcolm is recognized as a subject matter expert on AI, data mining, and business intelligence. An in-demand speaker, he has been featured in multiple events, including the IoT Big Data Summit, IBM Think, and Business and Tech Women's Network. We also want to welcome Russ Stothers, Product Manager at Copperleaf. Now, in this role, Russ specializes in AI, machine learning, and investment lifecycle management. Prior to Copperleaf, he was a senior leader in the renewable energy industry, where he focused on driving early-stage companies towards commercialization. Russ was also the chair for the International Electrotechnical Commission's Marine Energy Canadian Subcommittee. Well, it is great to have you both with us today. And at this time, I would like to hand it over to Russ. So, Russ, take it away.
All right. Thank you very much, Laura Beth. Hello, everyone. Thank you for taking the time for what I'm sure you'll find a very interesting discussion on AI-driven decision-making. The plan for today is Malcolm will start off and give you a perspective of the work they've been doing at Vale. He has some very interesting examples of some of those innovative applications that are using AI. I would like to present on AI and how it can use particularly in the capital planning process to make better informed asset management decisions, and some of the interesting applications we are currently working on at Copperleaf. At the end, as Laura Beth mentioned, we'll leave some time for your questions. So with that, and I'd like to pass it over to Malcolm to begin.
Excellent. Thank you very much. And I'd like to thank everybody for taking time out of, I'm sure, your very busy days. And I hope you enjoy and get some value out of the presentation today. To get started, I think it's not a surprise, but one of the key topics around AI is the fact that it's so pervasive and invasive. It's really part of our everyday lives. Everything from Netflix to autonomous cars. AI is the brains that drives how we move. In terms of AI and our general lives, it really is a game changer, and it's one of the biggest foundational elements that's transforming industry and our personal lives. Professor Stephen Hawking said about artificial intelligence that it's either going to be the best or worst thing to happen to humanity. Of course, we're all hoping that it's going to be the best thing for it. But it clearly is becoming one of the leading topics and very timely. At Tata, they found out, they did a survey of 835 executives and found that 84% of the companies see AI as essential to their future competitiveness. And in terms of asset management, it's really an incredible opportunity. When you talk about a component of it, which would be predictive maintenance, you really see that it can have a major impact on all components. You can improve your planned maintenance by 20 to 50%. Increase equipment uptime and availability between 10 and 20%, and companies are seeing a reduction in overall maintenance costs by 5 to 10. Now, these are quotes from Deloitte, but a lot of the major consulting companies that have done analysis on this, BCG, Ernst & Young, and others, these are all pretty common statistics that are quoted. And I can tell you from our experience, these are pretty reasonable expectations that we have. And one of the things, and I'm sure you guys know better than I do, that having a more reliable and stable operations also has a major impact in the not just your productivity of your organization, but can also have a major impact on the safety. And being in the industrial space, that's our #1 priority. And I think for all industry, it's an important goal that we should strive to achieve. In terms of the asset management function, I think that AI will and can participate in all the major components of the asset life cycle: acquisition, deployment, utilization, maintenance, and retirement. And I think the key to taking advantage of that is that we have an integrated asset management stack, and that we have a comprehensive digital vision to how that's going to fit into your asset life cycle. A value, we have a vision for it, and really it's sequential from left to right in terms of both what we're focusing on and where we see the immediate value. Okay, and so for us, it's really about linking the usage of our intelligent systems to how we make our decision-making process. Okay, so starting on the left, we have the areas of inspection and monitoring, where we believe that, or not believe, where we're implementing AI in a big way. And really that's through two concepts that we use inside. One is a digital twin, which is sort of an industry standard, although there's multiple different definitions for it. And then this concept of a digital analyst, which is consuming and leveraging AI for providing guidance to our reliability and maintenance engineers. Another area that we're working on, which is further down the stack, is around planning and leveraging AI and machine learning to optimizing how we do our maintenance planning and the control of those maintenance plans. And then the last piece, which we'll talk about in the presentation, just in a very quick way, is around more of the future vision that we have, which is this concept of an augmented assistant. And that's really the assistance of not just planning and monitoring and inspecting, but actually helping with the actual maintenance activities. Oops. In terms of the digital twin, where we're really looking at concepts of remote inspections, one of the key things, and it's one of the big topics, and I'm sure you guys have all encountered, is this evolution of IoT and IoT devices, which are really the way that you can capture the information. And what we focused on is really not so much trying to get it all in one place, but making sure that we understand and that we have a vision for all the different types of data sources that we have for our assets. And we look at everything from real-time information, which we get through things like historians and stuff, to nameplate capacities. And we also track things like, what's the maximum output we ever got from that particular asset? What are the minimums? What are the averages? And putting this all together, it becomes a data resource for us and creates the foundation of our digital twin. In terms of the actual digital analyst, which is the area in our stack that is actually consuming the data and providing it, we've really got it divided into 4 main functions that the digital analyst system does for us. The first is the concept of anomaly detection. And so what we're doing there is we're really looking at how the asset is running and determining if the asset is operating the way it's supposed to be. Now, the anomaly detection piece, which is using a machine learning, different types of machine learning algorithms, isn't giving you a lot of insight into why it's not operating correctly, but it's telling you that it is not operating correctly, right, based on historical patterns. And so that gives you a good indication. And if we don't have other pieces like failure prediction, which we'll talk about in a second, one of the useful things about an anomaly detection is it will cause an alert and for somebody to go actually take a look. So even though it doesn't give you a ton of insight into it, it will allow you to be able to identify that it isn't operating properly and may require a different need. We generally will, for our non-critical assets, stop at anomaly detection in our processes. The next thing besides anomaly detection is around failure prediction. And so we take the outputs of our anomaly detection, and now what we're trying to do there is we're trying to identify the remaining useful life of the asset, or when the asset's going to fail. And the goal for the failure prediction is really to identify it with enough time so that we can have take a preventative action, right? To make sure that the asset doesn't break down in field, and that we're able to plan and be able to take, as I mentioned, preventative action. And that does two things. One, you can plan around it, which allows you not to have productivity problems where the supply chain might slow down if it's a critical asset. And also working outside of the field and bringing the equipment into the shop or in a planned way is what we're seeing is a much safer approach to maintaining the equipment. The third and subsequent one is this concept of prescriptive analysis, which is really taking the output of the failure prediction and not just saying, okay, there's this amount of time of remaining useful life, but it's actually prescribing actions that you would take based on the results of the failure and anomaly detection. And the way we've implemented that is leveraging experts' opinions, and over time we get theirs in the system that we've built. It's kind of like the Netflix where you say, is that the right answer or is that not the right answer? And, was that good or was it bad? And over a period of time, it's starting to improve the answers, and we started seeding it with our experts' input. And the last part is closing the loop is to automatically generate the work order and have the system directly create it so that the reliability and maintenance engineers can take action. Okay. In terms of optimal PCM, we're in the process of implementing that, and that's exactly what it says, is trying to highlight the opportunity and when is the best time to do our maintenance. We're looking at multiple different components in there, other types of shutdowns. We look at coincidental maintenance activities that can happen. And the idea there is to take all of this information and run it through an optimizer to really be able to determine when is the best time and when should we schedule our maintenance activities. And it looks at the full asset life cycle, and it determines and we use cost as one of our main drivers, and also supply chain availability. Okay. So that's coming along now. We haven't implemented it yet in a meaningful way, and we're still in the pilot phase. And the last and more future vision that we see is this concept of augmented assistance, and it's really the cognitive analytics, which is where it's not just creating a work order, but actually how you want to perform that work order. Things like using three-dimensional real-time assistance, right? And eventually even using robotics to do some of the maintenance, especially where maintenance is in a hazardous area and it's hard to get a maintenance worker down there to go to repair. And we're doing bits and pieces of this, but we don't have a fully comprehensive strategy yet. And we're really focusing on the first two major ones as we go. In terms of some of the lessons learned in our journey, we've been doing this for about 5 years. Almost 6 now. I always keep saying it's 5. But we got started early and in a very modest way. And I'd still say we're proud of where we are, but there's a ton of way to go. But I thought maybe I'd just share some of the things that we've learned over the last 5 or 6 years. In terms of guiding principles, be flexible. and pivot easily. Some of the best opportunities we thought weren't, and some of the ones that we hadn't even considered turned out when we started doing the analysis to be our best areas of opportunity. Move rapidly. Timing's critical. Be a steer. I'm sure it's no different, but money matters, right? So, don't throw all your money into one area, but try and do it in a steer way. Fail fast, and that's really critical, is to make sure that if you're not having the success, pivot to where you can have some success, especially early on when you're trying to get adoption in the organization. Under promise and over deliver. It's easy to say and it's harder to do, especially when you're really excited and you want to get people on board. But I think it's critical. Chasing value. So always look for value. Always make sure how you're going to obtain value from the work that you're going to do. Don't assume just because everybody's excited that they're actually going to use it. And so you need to anticipate the success in that, and then see what the change management process is going to be in the organization to make sure that everybody's going to follow through with it. Okay. And then the last is, have a big vision, but obviously is starting small, and really building on your successes to be able to drive it out. In terms of case studies, I think one of the things, and it's sort of a lesson learned, but also a case study, is for those that have pursued this. You'll see that all the best machine learning and predictive work that you might do, it requires constant support. And you also find that as you put these things in, that if you don't have a process to sustain it, that they'll quickly fall by the wayside, whether it's because of change management or whether it's because the nature of the conditions are changing and your models are no longer accurately predicting what they're supposed to do. So having a sustainability processes is very important. It was one of the things that we did early, but out of necessity. Okay. And so we actually have a center dedicated to that. And the way it works is after we've built something and we're working with the reliability engineers, we have a cadence where we work on a regular basis, maybe weekly, monthly, it depends. And where we go through the models and the processes, we ensure that they're still working and that the business is getting value. But more importantly, or as importantly, we're making sure that the models are predicting and working the way that they're supposed to. And so it's a continuous feedback loop. And I'll tell you, it's really driven our adoption, because it's not like deliver a project and disappear. It's deliver the initial project, and then we just continue to work with the groups in an ongoing basis. I won't get into much of that. So far, it needs to be updated, but we're at 65 delivered products. We also have a training to really make sure people know what they're using. So we've trained over 500 people inside of Valley, so that they understand. And when people understand better, then they adopt much easier. And also we have a democratization program to try and help people start doing this themselves. I'll go relatively quickly through some of the key elements. One of the biggest and first ones that we had was doing our mobile assets, so our haul trucks. And it's really been not just our first, but our widest adoption. We have about 13 haul trucks inside the organization, and we're covering 80% of those globally. We're monitoring them, and we have predictive capabilities for them, and it's used extensively. For that, we predict the failures of the engines, the transmissions, the wheel assemblies, and the tires. Tires are a huge component of the equipment, and for those, we're able to extend the life, as an example with the engines. We're able to extend the life of the engines because we no longer rebuild them unnecessarily. We used to send them out, and just on an hourly basis, every 20,000 hours, we'd send them out to get rebuilt. But now we don't, and so we're able to rebuild the ones that need it prematurely, and we're able to extend the hours. And we've got about a 20% increase in the useful life of the engine. Sorry. Now this is just some quick views of the screens. I'm not sure if you can see them very well, but this is our Sentinella. This is our user interface. This is what the reliability engineers use. And this is also what we use in the AI center, which is at our sustainability center, where we have people that interact with the operations. And you can just see that each one of the trucks, as an example, and that's what these are, is haul trucks, you get a daily board and it shows if it's red. And if you were to click on that truck, it would show you what elements, what components of the truck that are causing that to be red. And over on the right, you can see this is sort of the feedback, and you'll see the thumbs up, thumbs down. And this is our feedback cycle to tell us whether the prescription, which is you probably can't see here, is the right prescription, what the right action to be taken is. Okay. In terms of fixed assets, we followed that same, if you look back on the anomaly detection and the failure analysis and those 4 processes, we follow the same thing. And here for our fixed assets, and this is one of our newer ones, we adopted the mobile first. We started focusing on fans. And for us, industrial fans are critical, both underground and above ground and in our plants. It keeps airflow. We're a dusty industrial environment, as you can imagine. And when the fans aren't working, we need to stop production. And so this was one of our natural ones. And again, we went through that same process. This one's more about doing preventative maintenance and identifying the remaining useful life, and where people can go in and make sure, for example, and it's broken down into components like bearings and the motors and stuff like that. And that allows them to be able to take advantage in maintenance windows to be able to avoid the outright failure of the asset. And this is just an example of our schedule and the assets that we're working on over the last year for those. I'll just go quickly. And one of the other interesting ones, which people generally don't consider, is that idea of remote inspections. And one of the big ones that we've started using more recently is satellite imagery, so orbital radar. And leveraging those to see monitor the ongoing conditions. In this case, we're looking at dams, but we're also looking at to use facilities like our open pits, and to see if the pits are shifting. We do this both from a maintenance perspective, but also from significantly for a safety perspective. Okay, and the last one, just as an example, is we do it with rail. And so what we're doing, and just to use a successful example, was identifying we have, I think, 9,000 kilometers of track through the rainforest. And obviously, it's not easy to inspect those manually. So what we do is there's cameras attached to our trains, and we pick it up and then we run it through machine learning to identify when there's anomalous conditions in there. And then we send out inspectors to make repairs to that in advance. And we have had in the past situations where, the train would get derailed and stuff. So that's it for me. I'm going to hand it over to Russ. Thank you very much for your time, and I look forward to any questions if you have at the end.
Great. Thank you very much, Malcolm. Really super interesting. I'm sure there's going to be lots of questions coming out of that. So from my side, I'd like to explore how organizations can leverage AI to predict future needs and optimize their decision-making. And we're really looking to help businesses maximize the value delivered. And it's really critical now more than ever, based on all the changing conditions we're having in our environment, about making the right decision at the right time. So what I'm going to do is I'm going to start with a quick overview of Copperleaf. I'll then actually jump into discussing how we're helping organizations employ AI to improve their planning decisions. And I'll conclude actually with a couple of interesting and innovative applications that we're now developing with machine learning and AI, one of which is currently available, and the other two are actually still in the development lab stage. So who is Copperleaf? Let's start there. Copperleaf provides enterprise-level decision analytics software solutions, specifically focused on companies managing critical infrastructure. We leverage operational and financial data to empower our clients to make investment decisions that deliver the highest value. Our software is focused on helping companies value investments and the resulting capital annual plans. Our vision is focused on that end goal of transforming how the world sees value. We are headquartered in Vancouver, Canada, and our solutions are distributed and supported by regional staff and partners worldwide. Our company is growing very strongly as the value of our offering is resonating with clients in asset-intensive industries. Industries such as this are natural gas, electricity, the water sector, oil and gas, and transportation, just to name a few. As I mentioned, we're a global company. Our clients span 5 continents across a number of industry segments. Here's a quick visual showing you the location of those clients. Our solutions are helping some of the largest and most complex organizations maximize value. And our products are helping these organizations to date manage $1.4 trillion in dollars in their assets. So Malcolm just provided you with an overview of how Valley has leveraged AI to enable insights and achieve improvements in reliability and operational efficiencies. This is represented here by the enterprise asset management journey. He provided a couple of great case studies on how they're leveraging AI to manage, for instance, their mobile assets and their fixed assets. For my discussion, I'll be focused on how we can leverage AI to improve our decision-making when we're determining which projects will make up the capital plan for not only the next 3 to 5 years in that short and medium term, but also longer sustainment needs over the asset's full life cycle. This journey is illustrated on how information from the enterprise asset management system, information is basically taken from the enterprise asset management system, and information could be asset condition, age, or other inspection information or trends. And that's used as inputs to determine which projects are created and when they're executed. Each of these projects will be scoped, costed and valued, and then assembled into an overall portfolio. I'll shortly discuss how AI is then used during the optimization process and the resulting selection of which projects to go into the short, medium, and long-term plans. AI-driven decision-making combines the power of AI with human judgment. This means that both humans and machines are important and critical to the process. While machines are able to execute repetitive tasks and calculations very quickly, humans are extremely efficient at using experiences and understanding contexts that simply don't exist currently in digital format. Complex decisions usually involve both structured data and also non-digital information. It is for these decision types in particular that AI can be used to generate possibilities from which humans can then be used to pick the best alternative. The key aspect here is that humans are not interfacing directly with the data, but with the possibilities and insights that are produced by the AI's processing of the data. Another important point to raise is that the capital planning decisions often can involve hundreds of millions of dollars. So the complexity and the scale of these decisions require both machine and human input to drive the best result. In the context of asset management, a lot of these principles have been incorporated. Here we're showing big data, which is basically drives the requirement for the type of projects that we create. The AI is enabled in the AI-enabled optimization of the plan, and possible actions are really equivalent to a scenario analysis, which enables you to see the impact of your different business decisions. It's important to emphasize that AI-driven decisions don't remove people from the equation. For complex business problems, we still need the collaboration of humans and machines. AI will just make this job easier, and this final decision will still be defined by human judgment. So now, when we taking a step back, when we're working with our clients in the implementation of our solution, we found that there's 3 critical factors that enable the successful implementation of an AI-driven decision-making. Let's start with culture. And culture is really all about people and behaviors. So companies that create the safe space to leverage innovations increase their ability to adapt and consequently become more competitive in their spaces. For creating an AI culture, it's important that there's a tolerance for mistakes. The first models won't be perfect. However, the models are designed to evolve and improve over time. When a culture of continuous improvement is embraced, it makes the adoption of technologies such as AI much easier. And that unlocks 2 important business capabilities. These 2 capabilities that are critical are decision quality and business agility. The combination of AI and human judgment can improve the quality of our decisions. And the utilization of AI also speeds up the whole decision-making process, bringing more agility to our businesses. These two capabilities are fundamental to improve our business's competitiveness. Once again, due to the complexity and scale of these decisions, both machine insights and human judgment are required to produce the best results. Finally, it's the role of business to then take into consideration information from the stakeholders to define a clear business strategy that will enable both transparency and trust. When companies are following a rational decision-making process, which is AI-enabled, in order to build their business plans, this creates transparency, which in turn helps build trust. So now, how do we create plans using AI to execute this business strategy? At Copperleaf, we've developed a solution in line with asset management best practices to empower organizations to make decisions that deliver the highest business value. This solution enables a decision-making process combining the power of AI with human judgment. First, we start with analyzing our assets. We use information from other systems, as I mentioned, and we draw that in and use this to drive AI-enabled predictive analytics. With predictive analytics, we create different asset strategies or plans for how to intervene against your assets in the most optimal way. Machines, which is AI, recommend the strategies, and then humans select the best strategy to move forward. So those strategies, those preferred strategies, are then promoted to the investment side of planning. Here, various investments are scoped, costed, and valued, and the business cases are fully developed. Multiple lines of business can all be managed in the same application, allowing full transparency and cross-business unit comparisons. These investments can then be placed into portfolios, and the portfolios are then optimized using AI that takes into consideration various constraints. Some examples of constraints that our clients use all the time are budget, such as a CapEx budget, or resources, that could be labor resources, contractor resources, as well as risk tolerances. AI generates the what-if scenarios to provide insights into the sensitivity of different levels of constraints. And due to both the complexity and scale of these decisions, it then allows humans to review the results and make trade-off decisions to create an improved plan. Once the projects get into, or the plan gets into execution, actuals and reforecasts can then be fed back into the Copperleaf solution to track how the investments are progressing when compared to the approved plan. This creates a circular process where adaptive planning can begin. The planning cycle no longer needs to be annual. More frequent updates increase your business's agility to react and respond to changing business conditions. Over top of this whole process is the value framework. This is a methodology that Copperleaf has developed so that each part of the business can speak the same language. It is the common currency that allows cross-business unit projects to be valued and compared on a common scale, thus enabling portfolios to be optimized with AI across the whole organization. I now want to basically drop in and talk about some of our machine learning applications. At Copperleaf, we have a process known as Copperleaf Labs, where we collaborate with clients to develop leading-edge applications. Last year, Copperleaf collaborated with several of our clients to develop a product that helps leaders understand the uncertainties in their investment plans. Performance prediction is the name of this product, and it enables organizations to gain accurate insights into the expected spend, benefits, and risks of their capital plan. It uses machine learning and statistical analysis techniques to predict the performance of investment portfolios based on historical data. This unique capability can help organizations account for cost and schedule uncertainties and use this information to understand the likelihood of overspending or underspending, and as a result, make contingency plans accordingly. Performance prediction utilizes past performance and machine learning algorithms to estimate how plans will perform when moving to real execution. So here we have a example of what a typical results may look like when running a performance prediction analysis for the approved portfolio. Here you see the original plan, which is the spend predicted by that plan for the years 2020 through 2028. After running performance prediction on this portfolio, what comes out is an expected plan. So based on the uncertainties associated with the investments in that plan, we produce what we are very likely to spend to execute this plan. We can also display a shaded range, which is the 90% confidence range that the spend will fall within this area. The product was launched late last year, so we're very proud to announce that we've now implemented this solution at our first client. The machine learning enabled prediction models had a 98% accuracy when compared to 2020 actual results. In 2019, comparing the actual spend there, the accuracy was actually 99%. So we've been really thrilled with how well it's producing results and comparing with clients' actual experience. For 2021, it is being predicted a considerable underspend with a very tight range of uncertainties in line with his client's expectations. The plans for the client will be they'll be using this performance prediction in their next planning cycle, which comes up in the fall of 2021. So we've just discussed performance prediction. Whoops. I now want to move on to the next application, and this is Valuation Insight. So Valuation Insight is once again being developed collaboratively with several of our clients. The goal of this solution is to help you identify which projects are not consistently and accurately evaluated with reference to similar projects in the past. Data consistency, and speaking with clients, data consistency can be one of the greatest challenges, and this tool will help provide insights to prevent gaming of the evaluation and therefore ensuring a high quality portfolio optimization. So once again, this application uses your historical data to train machine learning models that we use to flag anomalies in those candidate investments. So here we have an example of one of the prototypes that we're currently in development. You may not be able to read the details, but in essence, the table on the left would provide a list of the investments in the portfolio and then a flag highlighting the ones which require additional action or potentially investigation. Here we could be highlighting typical anomalies such as maybe missing or incomplete forecast information, you're missing some critical scoping details around where the investment is being executed or timing, or potentially there may be an unusually high or low benefit assigned to this investment. So those sort of outliers are identified with Valuation Insights. The figure on the right would provide a visual indication of the outlier based on some of the comparison the metrics that you like to compare your investments on. The overall objective of this application is to improve the quality of the investment data so that during portfolio optimization, it's able to determine the plan that maximizes the value delivered to the organization. So it's really critical that we enable good quality data, and this application helps organizations really achieve much better quality and consistency in their information. And the final application I would like to highlight is called Community Asset Modeling. So here we're showing the first two, and the third one, Community Asset Modeling. This is currently in the Copperleaf Labs and very much at an early stage of this application. And we're exploring several potential opportunities around this one. So what this solution does is it addresses the concerns that many of our clients have regarding the fact they have insufficient both quantity and quality of good asset data to create really those accurate asset strategies. By using a community approach and sharing insights across the community, users can create asset strategies with limited population data while ensuring data privacy concerns, as this is obviously a big issue these days. This is an opportunity to democratize an AI, to enable an organization to gain insights and develop their own AI models by leveraging a collaborative approach. We're very excited by this concept and expect to have a prototype developed in the very near future. In conclusion, the use of AI and ML technologies looks very promising for asset management applications. Within our organization at Copperleaf, we see great opportunity for this technology. And as I presented, we're exploring multiple potential applications. This is really just the beginning of our journey. We're fairly early in our machine learning journey, and as you can see, we've already developed one and have two more coming up. So we see great opportunities moving forward. AI-driven decision-making combines the power of AI with human judgment. This means that both humans and machines are important and critical in making the highest value decisions for the business. I can't stress enough that really AI is not displacing humans, it is really complementing, and we're using the skill sets from both in a complementary fashion. And finally, there are three enabling factors that are required to develop and drive AI-driven decision-making. The first one is culture. So as I've been discussed, we need to develop a culture that is based on both continuous improvement and a tolerance for mistakes. This culture will enable us to unlock key business capabilities such as decision quality and business agility. As mentioned, these are critical capabilities in increasing the overall competitiveness of our business. These capabilities will in turn allow us to create a strategy that's based on both transparency and trust. I would like to thank you very much for your time, and I want to pass it back over to Laura Beth for our Q&A session.
Excellent, and thank you so much, Russ and Malcolm, for giving us a lot to think about and this great insight today. And we've had a lot of questions come in, so you guys have said some things to pique the interest of our audience today. And so I want to get right into those to try and get to as many as we can. So question one here, if a company was just getting started with AI in asset health and reliability, where would you start?
Russ, if you don't, I can jump in. Okay, great. This is going to sound trite, but I would start with the area. Look at two things, and first of all, I would start with the actual asset themselves. Is one that's well understood in terms of data. Right, the data is the lifeblood of being able to do that. So I would start there. I would also start with one that's critical, right? One that's and again, it'd probably be the asset or asset class. I said it would be well understood because it would be critical, and that's where I would get started because that's where, as Russ mentioned, you're using. It's not displacing people, you're leveraging, right? And that's where you're going to be able to have the best feedback and see how your program's doing. So that's how I would get started. I would start with that asset that's the most important that you have your best data with. And the most important thing isn't to spend a whole bunch of time figuring out how you're going to get started. I honestly believe the best way is just to get started.
Yeah, thanks, Malcolm. And from my perspective, just to build on a little bit of that, from the planning side, the best thing to do is, like Malcolm's saying, is just get started with what you have. Begin with the data you have and build from there. Using AI is really a process. It's one of continuous improvement, and as you start doing it more, the results you get will improve over time. We often suggest to our clients to start in an area where there is an important and impactful problem. So exactly like Malcolm has just highlighted, focus on something that's critical. Potentially, also an area where you can gain some senior level of sponsorship and support. Since AI is a cultural change within the organization, it's a different way of approaching problems and thinking. It's really important to get that sponsorship. So by selecting a problem that is both important and impactful and really critical, you can get that type of sponsorship. And by looking for those key areas where the business is struggling, you can really gain support for this work and build a momentum, which is critical in moving forward.
Excellent. Thank you both for jumping on that question there. Next question here. You need to have a certain level of maturity across your maintenance programs to get started.
This is one of my favorite questions, and it's a continual battle. So because there's different varying degrees of thought on this, and I'll just get started. Russ mentioned culture, and we're very proud of what we built, but I will say that one of the things is that we don't have it everywhere, and that's because of culture. And I think I'll touch on that right now. Is that you need to get buy-in, and you need to get people aligned early on into that, and culturally, that's probably one of the most important things to do. I gotta be honest, I kind of got lost in my answer. Can you repeat it? That's embarrassing, but I did. Would you mind repeating?
So absolutely. Do you need to have a certain level of maturity across your maintenance programs to get started?
Yeah, sorry. Yeah, I don't believe so, because and the reason why is because we all have critical assets. Okay, and we're a company that's always struggled with our asset health and reliability process and our maintenance process, and so we're continually what we call going back to the basics and saying we need to establish the foundation, and there's no question that we do, right? And we need to keep reinforcing the basics. But the reality of it is, all of our companies have critical assets, and just out of nature, right? If these are critical assets that will stop your production or stop your ability to be able to sell, you've had to have advanced maintenance processes already in place. So while you may not have a great or mature maintenance practice overall, I guarantee you that for your critical assets, you've been taking care of them in a more advanced way. And so that's what I was saying is, for these critical assets, I think you can go up that maturity curve and take that next step to predictive maintenance or prescriptive maintenance, and you don't have to wait for all your asset and all of your maintenance strategies to get mature. And again, sorry for getting lost in that. I was just thinking about culture, and that's one of the cultural discussions that we're having and I fully agree that we need in our organization to improve our overall maturity. But I'm always continually fighting and pushing to say, well, yeah, but first, these critical assets, let's leapfrog. We don't have to wait for everybody else to get caught up, because we know these are critical. We know we need to look at them either for safety or productivity. Thank you.
Yeah, and on my side, I think Malcolm touched on there's no reason to wait. You have all the information you need. You can definitely start, and depending on your level of maturity, from the planning side, you can either start on the asset side and focus on the asset side and creating those strategies, or focus on the investment side. So during working with our clients, we always talk about identify where the problem is greatest in your business and start from there. And then as you develop the expertise, you can expand your capabilities over time. During implementations, we often do separate rollouts. So as clients maybe focus on the asset side and those critical assets, and there's burning issues there, we'll then create those asset strategies. And then as a separate phase, we'll then roll out the investment side and working around planning and optimization. So there's no time like the present to start. It's a learning process, and your level of maturity will only improve when you start going down this path. So we greatly encourage everyone to jump in, and then we can help you decide where is the best level to start, or where's the assets or portfolios, or where in between. So yeah, thank you.
Excellent. Thank you both. Next question here, which I love. Will AI replace reliability engineers or maintenance teams?
I guess we'll keep the cadence, because I'm sure you have some.
You than me. It was working well.
Yeah. And you already touched on it, Russ. I don't think so. We haven't seen it. Well, not in the foreseeable future. Okay. So, in fact, as Russ pointed out, I think it's critical that they work hand in glove, right? So we certainly haven't seen any of it. Okay. And, but in terms of culture, one of our continues to be a big challenge. Okay. We're a big organization. So, some places we have great adoption, some places we struggle. But getting people to understand that and to recognize it in earnest, right? We're not just saying it so that they'll jump in and then replace them, right? Because that's A, not the goal, and B, I don't think it would add the value. So we're not seeing it. I don't see it in the foreseeable future. You know, I'm not a Swami, so 25, 30 years from now, who knows? But in the next foreseeable future, we don't, and it's absolutely critical for both adoption and the successful development to have your reliability engineers participate.
Mm-hmm. Yeah, and from my perspective, definitely not. As I highlighted in my presentation, you know, definitely a combination of AI providing those insights and providing, you know, the analysis of the data, and then the human perspective, bringing up those non-digital pieces of information and overall business environment to creating those highest level decisions for the business. So we really see AI as, you know, just it's just a part of the decision-making process, and it's very much, you know, leveraging the strengths of AI and enabling decisions to be made much more quickly and agile. So when we talk about, you know, all the changes we've seen in our last year of our business environment with the pandemic and storms and everything, you know, decisions need to be made faster now. And using AI and leveraging that power just allows us to bring all the information together, make those decisions, and make them timely. So in effect, you know, we really see AI as helping those reliability engineers and maintenance teams and focusing on the problems that are both impactful and important to the business. So yeah, definitely, it's a collaborative, you know, so it's just a changing of skill sets and realignment, but the net gain is huge for the business, I believe.
Excellent. Thank you both for taking that question on. Next question here. What is the cost model used, total cost of ownership? What tool do you use to analyze the cost, internal, external? Who wants to jump on that one?
I'm just trying to think of, yeah, like we have reliability software from ReliaSoft that they use for total cost of ownership. We're generally where we're using. I'll try and use a real example because I'm not a reliability engineer myself, and but when we look at so when they're looking at like overall capital acquisition for new assets and stuff like that, that's done. They do that using a group of tools from a tool set. We happen to use ReliaSoft. Okay. But I know for a fact they still do tons of it on spreadsheeting, right? And I'm sure most companies still do a lot of that as well. But when it comes to the implementations for the ownership for costs that we use to make decisions around, you know, maintenance and stuff, we look at replacement costs. But again, I have a bit of a myopic view, right? So I look at the like the maintenance cost and the replacement cost. So when we're looking at, say, the engine failures, as an example, we're looking at what does it cost to rebuild and what is that cost of that money over if we can avoid that having to rebuild for 5,000 hours. I'm not sure if I answered your question. Again, I may not be where we've implemented a lot of it is more on the actual failure and more of the reliability, and not we're in process of doing overall maintenance optimization.
Yeah, on the planning side, we've, like Malcolm touched on, depending on the clients, there's a variety of approaches that we work with our clients to implement. As you say, spreadsheets are super common. So a lot of our clients come in with all sorts of calculations on spreadsheets. What we do is we work with them to create cost models and kind of two different approaches. If they're repetitive investments that are high volume and maybe on frequently done programs, it'd be more of a unit cost model approach where there's a specific, for a specific asset, they would be a standard breakdown between capital, OPEX, and resource requirements. If it's a more detailed project or a more complicated project, we would look at implementing a parametric model. So to allow them so the cost model would be driven by a variety of parameters that are potential specific to that project. Maybe location factors could be in there, or specific complexities around the actual execution of the project. So we often work with our clients to, within our product, we have a couple different cost model approaches. And we often find that during the planning process, those work really well. So kind of more a top-down approach. Moving into execution, most clients will revert to their bottom-up approach, which makes sense for tracking detailed project execution. And that's a different space, and it's not a space that the Copperleaf solution deals with.
Excellent, thank you both. Next question here, how do you ensure cross-departments in a company are using the same risk, legal, plant reliability, and regulation to have a common basis to be compared in the model?
I'm handing that one to you, Russ.
So can you just repeat that question? It was a bit of a long one.
Yeah, sure thing, yeah. How do you ensure cross-departments in a company are using the same risk, legal, plant reliability, and regulation to have a common basis to be compared in the model?
Mm-hmm. Yeah, great question. And a lot of clients struggle with the transparency. And one thing our platform does bring is the transparency across. We want to try to break down the silos so that everyone is using a common approach. So when it comes to costing, costing is one great example. For one unit in the business may cost a certain approach on a spreadsheet, for instance, and another may use a detailed bottom-up approach to do their costing. So by bringing our platform in and bringing in standard costing approaches, we make sure we have consistency across the whole business. And that not only applies to costing, but also valuing investments. So we find a lot of, within a business, different organizations or different parts of the business will value investments differently. And, safety is one of those, safety or reliability, all the risks, different groups may value them differently. And once again, it could be in a spreadsheet application or based on historical results. We've always done these projects. They're high risk. We think they should always be done. So by providing a common platform, a common framework, which is our value framework, it allows investments to be valued on that common scale and to make sure between different groups, everyone's doing the same thing. And the same thing applies to cost.
Excellent. Thank you for taking that one on. I want to slip one more in here before the end of the hour, and that's what type of timelines for this future vision are realistic or likely?
I'll jump in, Russ, sure. And then you can. Yeah. I can only speak for the approach that I shared with yours. I think when we got started 6 years ago, there wasn't a lot of companies that were doing this well. There was lots of companies getting started, really conceptually. And so that's why a lot of it, when we got started, we did ourselves, was just because we couldn't find companies to help accelerate it. So I would say that, ours is 6 years in, it's not that long. I think depending on how ambitious that you want to get, and it depends on, as an organization, but I think that you could establish on, critical asset failures. If you have the buy-in and support of the organization, which is critical, this is something that you could establish for several critical assets within a year, I believe, assuming you have the data and that you're capturing it and stuff. I don't think it's unreasonable that you could start an asset failure program within a year because, you don't necessarily have to start it yourself now. There's a lot of companies that have further along. There's accelerators. There's tools that are much more advanced than when we got started. I don't mean the data science tools. I mean tools that will address specific asset classes and stuff. But I think a year would get you out of the gate pretty well if you were focused on that. And to developing, reasonably a full asset health program for your critical assets, probably 2 or 3 years if it was a priority for your organization. Again, those are for critical assets. It'd be a guess. Yeah. I think each,
At Copperleaf, we are pushing hard to democratize AI, really to enable any user to gain insights and develop their own AI models leveraging these technologies. So we're working hard to accelerate this process. We're ramping up our capabilities and expect within the next several years, AI will be an even more important part of our suite. So we're investing really heavily in headcount, and we're constantly innovating. So yeah, there's no time to start but now, and we believe it's really super important.
Yeah. And maybe just contemplating as I'm talking also to try and help with some more specificity. If you were to pick an individual asset, and assuming you had the right amount of data, you're collecting it, you can get started with a failure model. And again, it's a bit different than looking at the overarching optimization of a capital asset lifecycle or whatever. It's not unreasonable that within I don't know, maybe when we started, we had a life cycle that would do a 8-week first delivery, right? Another 8 weeks of back and forth with the reliability engineers, and then another 8-week to put it into production. So you can get started pretty quickly. And in terms of investment, when we got started, most of this work that we got started with was able to be done without very much infrastructure costs at all. In terms of heavy lifting, now we've built out a full platform, and so that we can take advantages of other third parties' tools and stuff, as well as the ones that we build ourselves. But to get started, there's not a huge investment if you're just looking at individual assets to improving or piloting the concepts. And honestly, I think, your first foray could be done, have something of value within 3 months.
Excellent. Well, that's all the time we have today. And thank you to our panelists, Malcolm and Russ, for this very informative conversation, and to our audience for posting great questions and joining our program. We had a lot of questions come in, and just know that we will follow up later after the presentation. Just a reminder, today's webinar will be available on demand, and a link will be sent to you after the webinar. Have a great day, everyone.
Thanks, everybody.
Thank you, everyone. Have a great day.